Hello everybody, today we're going to talk about the sum and difference formulas. So buckle up because we're going to have a little bit of a long one. So the sum and difference formulas are as follows. Sine of alpha, this is alpha, a new one for you, plus or minus beta is equal to sine of alpha cosine of beta plus or minus cosine of alpha sine of beta. Now this, if we have a plus here, we have a plus here. And if we have a minus here, we have a minus here. So these match the sum and difference formulas depending on whether it's a sum or a difference. Now for cosine of alpha plus or minus beta, we have cosine of alpha times cosine of beta. And then notice here that the signs are switched. So if this is plus, it'll be minus. And if this is minus, it'll be plus. And then it'll be plus or minus sine of alpha sine times sine of beta. Now, tangent's kind of a doozy on this one. We have tangent of alpha plus or minus beta. We'll have tangent of alpha plus or minus tangent beta divided by 1 minus or plus tangent of alpha tangent of beta. Now, this all seems really crazy, but I promise you once we do a couple examples, you'll start to get the hang of it. So evaluating a trigonometric function, we can actually find the exact value of a function using the sum and difference formulas. In order to do this, you must select angles for which we know the exact values. So values that are in the unit circle. For example, sine of 30 is equal to 1/2. Okay, so we want to pick angles that we know the exact values for. So when we're looking at this first one here, we have cosine of 75 degrees. Now, 75 is not in our unit circle, but what is in our unit circle is 45 and 30. And when you add 45 and 30 together, you will get 75. So what we're going to do is we're going to say cosine of 45 plus 30. And we'll let our 45 be our alpha, and we'll let our 30 be our beta. So we took 75 and we broke it up to 45 plus 30. So what I'm going to do is I'm going to write out my equation that I'm going to use just to make it easier. Okay, do you have to do this every single time? No. Will it help when doing examples? Definitely. So we know that cosine of alpha plus beta is going to give us cosine of alpha times cosine of beta. And because it's a plus, we're actually going to use the minus here. So it's going to be minus sine of alpha times sine of beta. So now what we have to do is we have to plug in our numbers. So we have cosine of 45 times cosine of 30 minus sine of alpha, which is 45, times sine of beta, which is 30. So now what we'll do is we'll look at the unit circle. Okay, and we're going to say, what's cosine of 45? Well, that's root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 is another root 2 over 2. And sine of 30 is equal to 1/2. From here, it's just fraction multiplication. So we're going to multiply straight across. We have root 2 times root 3. That's going to give us root 6. 2 times 2 is 4. Root 2 times 1 is just going to be root 2. 2 times 2 is 4. Look at that. We have a common denominator, so we have root 6 minus root 2 over 4. This is our exact answer. Okay, there's no rounding. If we put this into a calculator, we'll find cosine of 75 when you just pop it in. But this is an exact answer. This is what I'm looking for in this section. Okay, so let's go on to example number 24. We have tangent of 105. And before I say this, before we do this one, I want to tell you that there's more than one way that you can break up 105. I'm going to pick 60 and 45. Okay, but there are other methods you can use. My way is not the only way. So this is going to be our alpha. This is going to be our beta. Okay, so we know that tangent of alpha plus beta is going to give us the formula tangent of alpha plus tangent of beta all over 1 minus tangent of alpha times tangent of beta. Okay, so this looks like a mess, but it's going to get easier, I promise. Okay, so first thing we have is tangent of 60 plus tangent of 45 all over 1 minus tangent of 60 times tangent of 45. So now we're going to plug in our numbers. Tangent of 60 is just root 3. Tangent of 45 is 1. And then we have 1 minus tangent of 60 is root 3. Tangent of 45 is 1. So I'm just going to say it's 1 times square root of 3 is just root 3. Now, we know we can't stop here because we cannot have a radical in the denominator. So we have to find a way to get rid of this root 3. And please don't say, oh, we can just cross them out, because that is only possible if they were being multiplied. So in order to get rid of something like this, like a binomial here in the denominator, you have to multiply by something called a conjugate. And the conjugate would be these two numbers, but in the middle, instead of a minus, you would have a plus. And when we multiply by the conjugate, it actually gets rid of that middle term, which will give us a whole number in the denominator. So what we're going to do is we're going to distribute. We have root 3 times 1 is going to be root 3. Root 3 times root 3 is just 3. Then we have 1 times 1, which is 1. And then we have 1 times root 3, which is just root 3. We're going to clear this up in just a moment. The bottom is just you're going to multiply the first two numbers and the last two numbers. So we have 1 times 1 is 1. Root 3 times root 3 is positive 3, so we have 1 minus 3. And again, we could FOIL this, but the whole point of a conjugate is to get rid of that pesky middle term. So we're going to keep reducing this. Whoop. Okay, root 3 plus root 3 is just 2 root 3, and 3 plus 1 is 4. And the bottom will become 1 minus 3, which will be negative 2. We're almost done. We're going to divide each one of these right here by negative 2. So 2 root 3 divided by negative 2 is negative root 3. 4 divided by negative 2 is negative 2. This is our final simplified answer. So I think the toughest part here was knowing how to get this radical out of the denominator. We have to multiply by something called, and I'll write that up here just in case you guys forgot the word, it's a conjugate. And a conjugate example would be a plus b. The conjugate would be a minus b. Okay, let's do another example. This time with radians, because I know how much you guys love radians. So pi over 12 excuse me, is not on the unit circle. But we do have some numbers that are on the unit circle. Now, my suggestion, because everybody just hates radians, is to convert the radians to degrees. But please notice that we are going to cleverly convert to degrees so that no one would really know. So if we convert pi over 12 to degrees, we're going to get 15 degrees. And in order to do 15 degrees, we'd have to do sine of 45 minus 30. Or sine of pi over 4 minus pi over 6. So just like that, you don't even have to, you can erase this part right here. Pretend like that never happened. We use radians the entire time. Okay, so now that we know what our alpha and beta are, we can actually now use the theorems up here. Oh my goodness, I don't know why this keeps happening. Okay, so because we have sine of alpha minus beta, we have sine of alpha times cosine of beta minus cosine of alpha times sine of beta. And I'm going to go back down here. Okay, so now that we have that, we know that our alpha is pi over 4. So we have sine of pi over 4. We have cosine of pi over 6 minus cosine of pi over 4 times sine of pi over 6. So we just plugged in everything that we had. So now that we have this, we can just look at the unit circle. Sine of pi over 4 is just root 2 over 2. Cosine of pi over 6 is root 3 over 2. And then we have minus. Cosine of pi over 4 is another root 2 over 2. And sine of pi over 6 is 1/2. We're going to multiply straight across. Root 2 times root 3 is just root 6. 2 times 2 is 4. Root 2 times 1 is root 2. 2 times 2 is another 4. Again, we have another common denominator. We don't even have to do math here. We have 6, root 6 minus root 2 all over 4. We can't reduce this. We are done. Okay. We're going to do another one. We have tangent of 11 pi over 12. And if we convert that, again, we can convert that by multiplying by 180 over pi. We will get 165 degrees. Technical difficulties are back. Okay. And in order to get 165 degrees, you would have to do tangent of 135 degrees plus 30 degrees, which is, again, tangent of 3 pi over 4 plus pi over 6. Again, look at this. You used radians, but you really used degrees. Okay, so we have tangent of alpha plus beta, and that's equal to tangent of alpha plus tangent of beta all over 1 minus tangent alpha, tangent beta. So now we're just going to plug and chug what we have. We have tangent of alpha, which is 3 pi over 4. And then we have tangent of beta, which is pi over 6. And we're going to put that all over 1 minus tangent of 3 pi over 4 times tangent of pi over 6. So now what we're going to do is we're going to look in the unit circle. Tangent of 3 pi over 4 is, what is that, -1. And then we have tangent of pi over 6 is root 3 over 3. And that's all over 1 minus -1 times root 3 over 3. Now this is going to be a little trickier than the other ones because we have to find some common denominators here. We can just turn this 1 into a 3 over 3. So now we have -3 plus root 3 over 3. And then we're going to be dividing that by 1 minus -1 times root 3 over 3. So we have really 1 plus root 3 over 3 here. Okay, we're getting very close to the end here. It's going to be a little bit more work. So I'm going to find a common denominator for the bottom as well. This is going to be 3 plus root 3 over 3. And I don't know if anybody remembers, but there's a little trick. You have -3 plus root 3 over 3, and then you have 3 plus root 3 over 3. When they have the same denominators and you're dividing by the fractions, they actually can go away. So now we have -3 plus root 3 divided by 3 plus root 3. Again, you can't cancel anything out here, unfortunately. Okay? You might think you can cancel out these 3's. That's a no-go. They're not being multiplied or divided here. So what we're going to have to do is we're going to have to get rid of this root 3 in the denominator by multiplying it by its conjugate. And the conjugate is 3 minus root 3 here, 3 minus root 3 here. So we're going to have to FOIL. So -3 times 3 is going to be -9. -3 times -root 3 is going to be +3 root 3. 3 times root 3 is going to be another +3 root 3. Positive root 3 times -root 3 is -3. Now 3 times 3 is 9, and root 3 times -root 3 is going to be -3. We're almost done. So we have this -9 and we have this -3. That's going to give us -12. We have 3 root 3 plus 3 root 3. That actually gives us 6 root 3. And then 9 minus 3 is just going to be 6. Now, each of these terms here is divisible by 6, so we're just going to reduce it one last step. -12 divided by 6 is -2, And 6 root 3 divided by 6 is just root 3. So here is our final answer. Okay, so we also have questions like 27. So if sine of A is equal to 4/5, where A is between 0 and pi over 2, so we know that sine is in the first quadrant, and cosine of B is equal to -12/13. Okay, and it's between pi over 2 and pi, so we know that this is in the second quadrant. So what we want to do is we want to find the exact value of sine of alpha minus beta. Now, before you do this, I highly suggest that you sketch out what's going on here. So we have one angle, alpha, and it's in the first quadrant. And we know that alpha, in this case, is going to be opposite over hypotenuse. So we have 4 over 5. So here's our alpha. We also have a beta, which is in the second quadrant, like so. And we know that cosine is adjacent over hypotenuse. So now we have our triangles. We can actually use Pythagorean triples to find the other two sides. So we know here that this adjacent side is going to be a 3 because it's a 3, 4, 5 triangle. And we also know that 12 and 13 are also part of another Pythagorean triple. If you're not familiar with the Pythagorean triples, you can always use the Pythagorean theorem in order to find the other side, but it's easier just to remember some of your Pythagorean triples. We'll know that this side right here is going to be equal to 5. So now we figured out our two triangles, and now we're looking for sine of alpha minus beta. I have no idea what just happened there. So we have sine of alpha minus beta. We know that that is going to be sine of alpha cosine of beta minus cosine of alpha times sine of beta. Now that we've drawn out these two triangles, we can actually find all of these things. So sine of alpha is actually given to us. It's 4/5. Cosine of beta, also given to us. It's -12/13. And this is why we drew the triangle, because it's about to get a little bit more tricky. Cosine of alpha is not given to us, but cosine of alpha is going to be the adjacent side over the hypotenuse, or 3/5. And sine of beta is not given to us, but we know in this triangle here, it's going to be our opposite side over our hypotenuse. So we know it's going to be 5/13. And now that we have all these numbers, all we have to do is multiply straight across. So 4 times -12 is -48. 5 times 13 is 65. And then we have 3 times 5 is 15. 5 times 13 is still 65. Look at that. We have a common denominator. -48 minus 15 is -63 over 65. That is our answer. Now what we can also do is we can find other values here. So we're going to find tangent of alpha minus beta. And if you guys remember, we have tangent of alpha minus tangent of beta all over 1 plus tangent alpha tangent beta. I think a lot of kids start to really not like the tangents in this section because there's always more work that needs to be done. So we already have our triangles, right? We are going to use our triangles again to figure out what's going on here. So tangent of alpha is going to be our opposite side over our adjacent, so 4/3. And tangent of beta is going to be our opposite side divided by our adjacent side, or 5 over -12. For our bottom, we have 1 plus tangent of alpha, which we found was 4/3, times tangent of beta, which is -5/12. So now what we have to do is we have to start simplifying. Okay, so we have in the top, we can find a common denominator of 12 by multiplying this by 4 over 4. So we have 16 over 12 plus, because two negatives make a positive, 5/12. And in the bottom, we have 1 plus 4 times 5, or actually it's going to be a negative because that's a negative 5. So minus 4 times 5, which is going to be 20. And then we have 3 times 12, which is 36. I know for my next step, I'm going to have to combine these. So I'm just going to turn this 36 into 36. So we're going to continue going here. We have 16 plus 5 is going to be 21 over 12. 36 minus 20 is going to be 16 over 36. So now we have a fraction over a fraction. So we're going to keep change flip. We're going to keep the top, 21 over 12, change the operation, and flip the denominator. Now before I multiply this, I'm actually going to reduce. 12 goes into 36 3 times. And we have, oh, this is actually a 16. Okay, and we can't actually reduce anything here. So we have 21 times 3 is 63. 1 times 16 is 16. That is our answer here. So the last thing we can do with these is we're going to verify trigonometric functions. Like I told you, it's a long day. We're almost there though. We're going to verify that cosine of 90 plus x is equal to negative sine of x. Now obviously this left side is a lot more tricky than the right side. So we're going to call our 90 alpha and we're going to call our x beta. So just to bring down that identity, we know that cosine of alpha plus beta is equal to cosine of alpha cosine of beta minus sine of alpha sine of beta. Oops, I accidentally ran into the other one over here. Okay, so we know that this is going to be cosine of 90 times cosine of x, and then minus sine of 90 times sine of x. And we're trying to show that that's equal to negative sine of x. So cosine of 90 is just 0 degrees. It's just 0, not 0 degrees. So we have 0 times cosine of x, and then sine of 90 is just 1. So we have 1 times sine of x. This actually cancels out to be 0, and then this will be minus sine of x. So it will be negative sine of x is equal to negative sine of x. And that is done. So for the next one, we want to solve over the interval of 0 to 2 pi. So basically our answers are going to be in the unit circle. So we have sine of x plus pi over 2 plus sine of x minus 3 pi over 2 is equal to 1. So when you look at this, this is going to be expanded in its own way, and this is going to be expanded in its own way. And it's going to get really ugly before it gets any better. So we're going to call this alpha, we're going to call this beta, and we're going to do the same thing over here. So sine of x plus pi over 2, we're going to expand it to be sine of x cosine of pi over 2. And that's going to be plus cosine of x sine of pi over 2. Then we're going to expand this guy as well. And we're not going to fit it all on the same line here. So we have sine of x minus 3 pi over 2. That will give us sine of x times cosine of 3 pi over 2. And like I said, we're going to have to kind of bring it down here a little bit. We're going to have minus, because there's a minus in there, cosine of x sine of 3 pi over 2. Okay, so like I said, this is getting really gross before it gets any better. And remember that this is all equal to 1. So when going through, we have sine of x times cosine of pi over 2. Cosine of pi over 2 is just 0. So we have sine of x times 0. Then we have plus cosine of x times sine of pi over 2. And sine of pi over 2 is just 1. So we have cosine of x times 1. Then we have sine of x times cosine of 3 pi over 2. And cosine of 3 pi over 2 is negative 1. it's 0. So we have plus sine of x again times 0. And then last we have cosine of x minus cosine of x times sine of 3 pi over 2. That is cosine of x, and sine of 3 pi over 2 is equal to -1. And again, that's all equal to -1. We can cancel this out, and we can cancel this out, and we're left with cosine of x. These two negatives here will make it plus cosine of x is equal to 1, which means we have 2 cosine of x is equal to 1, which means cosine of x after we divide both sides will become 1/2. And this happens twice in the unit circle. And again, it tells us we want our intervals in radians. So x will be pi over 3, and 300 is 5 pi over 3. Again, what we did was we used the new formulas that we learned today to break each one of these up, and then we can start canceling, and then we solved for cosine and then x. So that's all we're doing today, thank goodness, right? Because that was a lot. So what you're going to do is you're going to go to Google Classroom, you're going to see what we have for work today, and if you have any questions, you can always find me in the Google Meets. I'm always welcome questions. I want to help you. I'm also available through GoGuardian. Have a fantastic day.